Excuse me. So the next kind of logical question is, so where does this difference come from? Could be that the difference lies in the total number of puppies born. You've got X number in one, slightly more in two, and then fewer in subsequent parities. Or you could have a difference in the number of live puppies that are born, or because of the way at CCI we count our dogs. In our case, it could be a difference in the number of puppies surviving to weaning. In other words, you could start with the same number of puppies, but wind up with fewer alive at weaning time when that particular count that you saw is made. So if you look at total puppies born, some kind of box and whisker plot that shows up fairly well. You'll notice that this line in the center of each of those boxes is the median, and you'll notice it does tend to go down slightly from parity 1 to parity 5. One neat thing to notice that jumps right out at you from the data is that if you look at the size of the rectangle, the rectangular vertical bar on each of those, right? That's the kind of the middle 50%, the upper and lower kind of interquartile ranges. The more variability you have in the number, the larger that rectangle is going to be. And what's fascinating is that you have very little variance in parity number 2. I mean, you're right in there about 9.5 puppies. That's about your median, 9.5 pups born per litter. And the interquartile ranges run from basically 9 to 10. So you've got one pup in there. If you travel out to parity 5, it's very interesting because now you've got incredible variability. So clearly, I mean, something interesting is going on. Your variability is picking up. In other words, that range of puppies that you might see in any particular litter is going up as the parities get higher. And I should say that for analysis purposes, I only looked at dogs that had at least 3 parities, because again, in CCI system, if a dog had any sort of kind of medical problem that kind of would have impinged reproduction, we would have pulled it out of breeding. But I was afraid that would kind of affect the data analysis, because animals with problems would be left in parity number 1 and not. So I should just, as a methodological point, tell you that I pulled out any dogs that had fewer than 3 litters. So in analyzing it, you've got a highly significant p-value there, and I should also say that although it's not on the slide, we looked at the difference between labs, Goldens, and hybrids, and breed was not a significant figure. Looking at stillbirths, you can see that the frequency chart on the right may not be the clearest thing for you, but in about 40% of litters, you've got 0. Something like almost 30%, you've got 1. So we don't actually have too many stillbirths at CCI, and again, you've got slightly increasing variance as you go up from the first parity onward, but it's significant, but not enough to account for the difference that we saw in the beginning. So although I waffle here on this slide, the real story is that the parity actually tends to affect the total pups born. That's the lion's share of the difference that you observe. For us, the number of stillbirths wasn't that significant. We saw it in our lab populations, in our golden populations, in both, and it's at least in our breeding program, it's a highly significant effect. So the other thing we wanted to ask about this parity effect is, does it affect? So that's the dogs that are produced and enter our program. Does it produce the fates? Does it influence the fates of the dogs? In other words, the outcome. So all of our failures are coded either behavioral or medical, and to avoid kind of the problem that's known as sensor data problem, a dog can fail for both reasons. In other words, a dog that, let's say, is failing for hip dysplasia still receives a rating. Would it have passed behaviorally, or would it have failed behaviorally? So So a dog can, have hip dysplasia, but also be a behavioral failure. As an artifact of our database, it's important to note that for this analysis, I couldn't capture what the reason was the dog was released behaviorally, although I have veterinary diagnoses for why the dog failed medically. So the first analysis, looking by parity at medical releases, the difference from parity 1 through parity 5 was not significant, and it's kind of as the graph the graph shows. You're somewhat up and down, but essentially it's the same from start to finish. It really didn't show any kind of trend that would enable us to say, as parity goes up, and that actually wasn't unexpected. It was actually this behavioral piece that was unexpected. This is behavioral failures as a function of parity. Suddenly we get this highly significant effect that really we didn't really expect, to tell you the truth. It kind of jumps off the graph at you. If you look at the p-value, it's less than 0.01. That was a real puzzle to us. Honestly, I was figuring neither medical nor behavioral releases should really be affected. So getting those results caused me to do a lot of kind of further thinking about what the agency could be that is operating on these dogs to have them kind of fly out of the program at higher numbers in the later parities. So, looking at the kind of practical conclusions of all of this, we're thinking about, perhaps, there's a ceiling that we need to think about in terms of how many times you want to breed a particular bitch. Again, in terms of heritability, at least in our population, litter size has a heritability of about 0.36, which is pretty respectable in terms of being a trait that you can change through selection. And so it may be that when you're calculating a breeding value in an animal, perhaps looking at litter size as one of those traits might be worthwhile, so that we don't see that fall off in higher parities. And for some particular behavioral traits, including a term for parity in your model of genetic merit might be important, because it might allow you to get a more accurate estimation of an individual animal's value. In other words, if I'm looking at a dog, or let's say if I'm looking at a litter with a particular success rate and trying to compare an individual from that litter with an individual from another litter, it may be important for me to know that this litter was out of a DAM's first parity, and this litter was out of the DAM's fifth parity, because that parity is obviously having an effect, or at least may be having an effect on the behavioral measurements that we're making. So that's those are sort of pragmatic ways that we can accommodate it. Not the most satisfying thing, because you not only want to, although kind of the first piece of my job is to try to accommodate it in a pragmatic aspect and account for it. There's part of you that's obviously wanting to understand, so what's the why? Why is this happening? What's the mechanism behind it? So we kind of looked at all sorts of different things, and happened to be talking to some research scientists from what was then IMS, now is part of Procter & Gamble. And they had some interesting data, experimental data, on the docosahexaenoic acid levels, which is DHA. It's been in the news quite a bit because it's a fatty acid that does a lot of things for a lot of people, and people take it as fish oil supplements and all sorts of things. And it turns out that DHA is a highly conserved nutrient. In other words, we mammals don't like to give it up very easily. We hang on to it fairly tightly. It's hard to get your body to metabolize it or excrete it, except under one condition, and that condition is pregnancy. And mammals get pregnant, and suddenly it's like somebody turned the tap on, and the DHA gets transferred over to the developing animals, and continues to get transferred to the young animals via lactation after they're born. So that was a somewhat kind of suggestive, that and some other data was somewhat suggestive that, wow, I wonder if DHA could be playing a role here. So we decided to take a look at, you know, if we change the DHA levels of, well, make a long story short, if we highly supplemented certain of our dogs with DHA, will we see any differences? And so we took 32 litters and divided them between 3 treatment groups, you know, kind of a baseline, normal diet, moderately, and then a highly supplemented diet with DHA. Had these 3 treatment groups, and what we sought to study was the following hypothesis, that what's happening is the DHA that's stored in the dams gets mobilized to meet the needs of the puppies, and then these you know, sacrifice nutrients, as I say in the slide, but really we're talking about the essential fatty acids profiles. The fatty acids are not completely replenished between litters. So in here, if you look at the DHA content in the red blood cell, DHA is a constituent of blood cells. If you look at the graph of this, and this is actually done in prior work, not on our animals, but if you look at dogs that have, you know, in these 5 parodies and look at the content in DHA, you get a significant and pleasingly linear drop-off between parodies, and this kind of lent some weight to this hypothesis that we were kind of developing. So what we did, as I said, is we took 3 treatment levels. We decided we would feed the dogs from the time they were bred to 3 weeks after weaning was over. That ensured that the DHA levels circulating in the mom were available both for at least we believed that it ensured that the DHA levels circulating in the mom were available for utilization by the fetus and also by the offspring who were nursing. And then we did a kind of two different outcomes. We did what we call the homing ability test. It's like an open field test almost, about 8 days after birth. And then we did a simple, you know, this dog will either succeed or fail, you know, looking at its fate in our program. And to be honest, you know, I was very surprised by the behavioral outcome, as I said, in this parity study. And I had fairly low expectations for this study. Which might say something about, you know, wait until Mundell picks and then go the other way. But there's so many, I mean, it's one of those things where maybe you can't see the forest for the trees, but I see so many variables kind of involved in the success or failure of any individual dog that I really, to be honest, was a little bit skeptical that, you know, 18 months down the line, you know, this DHA supplementation could have a heck of a big effect. But we did this experiment. So this is the first test that we do. This is what we call the homing test. This is a circle that actually is the inside of the kiddie pool that we use for whelping. So it's an environment that's essentially known to the puppies. And what we do is those of you who've been around litters of dogs know that if you separate one of the dogs at you know, somewhere between a week and 2 weeks of age from the rest of the litter and mom, it's going to struggle to get back to. So we would take a puppy out, put it in an empty pool that just had some towels down that were kind of scribed with these circles at these, you know, 10 inches, 15 inches. We oriented the puppy towards a blanket that we had left in with the dam for several days that presumably had her scent on it, and then we kind of gave the pup a little bit of time and measured its progress towards the blanket, and we kind of counted how many circles it reached. So nothing revolutionary. But interestingly enough, if you look at our 3 treatment groups, these are 8-day-old puppies, and it's the success percentage of the dogs who have gotten 15 inches towards the rag that smell like the dam. And the same letter or different letter is significantly different in our effect. It kind of overcame well, I think we're using 0.01 as our significant p-value here. So the high and medium levels were not significantly different, but the high and medium levels were significantly different from the low level. And if you look at that, that's about 10% of the low supplementation puppies achieved this 15 inches or greater towards the target, whereas in the high, for example, you had over twice that number making it. So, and then what's interesting was if you look at the graduate numbers of this sample set that we used in the experiment, this was really kind of a shocker. The highly supplemented dogs succeeded at 38%, the medium 28%, and the low 25% across parities, I should say. And interestingly enough, if you look at the behavioral releases, you see the opposite. 62% failure for the highly supplemented, 75% for the low. So suddenly you have a very kind of significant difference between the high supplementation group and the medium and low supplementation groups. And this is, I should say, it held out quite well, and I don't have slides with me, but the effect was actually slightly more pronounced if you then segregated by parity, which was the kind of initial motivator for the study to begin with. What was also interesting is, so you get this highly supplemented group, and they've got fewer behavioral releases than the medium and low, but then when you looked at the kind of behavioral release, which we also tracked for this experiment, they're different. So of the dogs that failed our program, okay, the group that was highly supplemented with DHA is suddenly failing for assertiveness, which is at a higher rate than our normal dogs, and as you can see there, a much higher rate than the dogs that received only low levels of supplementation. Distraction is the other way. Stress is the other way. So, I mean, what's interesting about that is, I mean, you know, if you think back to like Meg's talk this morning, you know, suddenly, or if you think about, you know, Brian Hare's hypothesis that you know, you could see a lot of the similar behavior in wolves that you see in dogs, if only they weren't so doggone nervous about, you know, us people. Suddenly, some of the you know, biochemical changes that you're seeing are having an actual measurable effect on the behavior you're observing, which is you know, really you know, it's a pretty cool idea. And you know, it had to kind of rethink all my willed ignorance about my own diet. Not that I've acted on it, but. So the next thing we did that again and for me was a slightly unexpected result was and really highlighted the kind of complexity of this whole enterprise. Was we looked at you know, could we affect certain things with probiotics, and so. There are periods in the CCI system, if you think back to that kind of service animal CV I documented at the beginning, there are certain periods of kind of predictable stress for the animals. You know, whenever they change their environment, because changing an environment is changing a lot of things, it's a fairly stressful time. So when they leave the litter to go into the puppy raiser's home, when they leave the puppy raiser's home to enter kennel housing, when they have, for other reasons, diet changes, when they leave the kennel to work with the graduates. These all tend to be times when we see kind of GI problems with the dogs. if we're changing, the amount of time the dog is being asked to work, which is quite common when we go from training to that 2-week period when the graduates come, or the students at that point come to work with the dog's workday suddenly gets longer. That adds a certain problematic for at least the dog's GI system. Dietary indiscretion is a big part of a lab's life. That's a constant problem when they're living in a home. And of course, illness. So what we're trying to do is there's sometimes a kind of almost this feed-forward loop between stress and excuse me, GI abnormalities that we're always trying to break, and we come at it in behavioral ways, we come at it medically. Clearly, when you take an animal and put it into a puppy raiser home, one of the things that might happen while they're, unfortunately, just at the time they're trying to be housebroken, is you get, for any variety of reasons, you get diarrhea, and so the typical solution there is restriction of the diet, and perhaps some sort of either antibiotic or antiparasitical given by the veterinarian. So one of the things that we wanted to figure out is, could we impact this kind of this loop that I was describing, this kind of stress GI problem loop, by supplementing pups in the litter with a probiotic. Bifidobacterium animalis is a canine-derived strain. In other words, it was isolated and then cultured from the GI tracts of perfectly healthy and happy beagles, and then tested or screened in other populations of dogs to show that it had at least some colonizing ability and function. And so we wanted to take a look at, could this perhaps, especially in the kind of more immature system of a puppy, exert some sort of protective effect on the dog. So our first study was at 5 weeks of age. We provided puppies, and then kept that up for several weeks. Dog was if you'll remember, during this period adopted into the puppy raiser home, and we kept it up then for 6 weeks. So one of the things we looked at was on the puppies we supplemented versus the puppies we didn't supplement. We looked at a sort of common stress marker, alpha glycoprotein, and didn't see any effect versus a sham treat that we were given, kind of a matched sample of puppies. But if we look directly at the stool scores of the pups, we saw a major effect, highly significant effect. And I should explain that we score stool, basically number 1, a stool of score number 1 would be like extreme liquid diarrhea coming out of a dog. 5 would be like a brick dropping out of a dog. So 2 is significant diarrhea. So clearly the probiotic was exerting some sort of protective effect in terms of minimizing or at least reducing the incidence of diarrhea. And we also looked at antibiotic usage. In other words, we simply counted the number of prescriptions, frequency of prescriptions for antibiotics that veterinarians prescribe to our puppies after arriving in the puppy raiser home or before leaving the breeder caretaker home. And again, there's a significant difference, something on the order of 8% versus 28%. Interestingly enough, the puppy raiser, as you might expect, was much happier with the dogs that were on probiotics, and that's not a, it's funny, it's we all laughed, but it's not a trivial result in our world, because our puppy raisers again are volunteers. They're not necessarily dog people. They're good-hearted people that we hope will become kind of dog people. But they love dogs and love the idea of helping people. but you know, they don't necessarily sign on knowing that diarrhea is part of the immediate future. So we were happy with this result. Our we cultured a number of microflora populations out of the stool of the pups in this project. The one difference we saw a lot of negative. In other words, the counts were the same between the supplemented and unsupplemented dogs. This is actually kind of a poor slide in terms of readability, but the one difference that we really did see was in E. coli counts. The E. coli on supplemented dogs was much significantly lower than the placebo group. So, and here's a list of other microorganisms that we tried to culture and count, but didn't detect any count changes. To sum up, and this was enough to kind of launch us on a road of a much larger. This is a fairly small population that we looked at with this. I forget exactly, but it was on the order of 65 animals. We're kind of now doing several hundred animals, but the promise there was the fact that we were able to get by with significantly fewer antibiotics when the puppies were making the transitions into puppy raiser homes. The fact that diarrhea was minimized, and to be honest, I mean, diarrhea at this age with a fairly immature gut is probably, medically speaking, is not necessarily the biggest deal. But in terms of this is their launch into housebreaking and training with the puppy raiser, it actually is a significant deal. And so it's something that we're more than happy to kind of push hard on to try to increase that effect. And so we're currently doing a kind of a larger study with a much higher fraction of our population. But in any way, the kind of wrap this up, I hope I've shown that our modern programs, in other words, our modern working dog groups, are really still reaping the benefits of the kind of the imbalance and plasticity that was induced and induced kind of by themselves in the domestication of the dog, and we've still got a long way to go. And our breeding programs are only now really learning how to take advantage of that plasticity to make dogs even more effective for what we want. And I think kind of as Scott was saying, we're changing what we want fairly frequently, and it really is astounding that the dogs can keep up. But I hope I've highlighted with pointing out some somewhat confounding or at least unexpected results, that there's still a large place for basic research. I mean, sometimes we tend to talk as though everything is known. We're right on the cusp of, understanding everything about training and rearing and the whole husbandry and what's going on. But really, we're not. There's a ton of work yet to be done, and I think I think. As we do try to, as I said, kind of move from a craft into a more of a technology, I think there are a lot of areas where we can industry, this is in the case of Procter & Gamble and CCI, but also academia and individual private breeders who still house the vast majority of the canine variability that exists in the world, can really accomplish a lot by working together. And again, I end with my plea that there's plenty of evidence to not go down the road of being tempted into being too reductionist at this stage, because there's a lot out there that's still kind of complex. Thank you. Are there any? Yes.